Today I am taking up a topic namely harmonic function. A function phi, maybe like x squared minus y squared or xy, like that. A function phi which satisfies the Laplace equation. This is called Laplace equation. A function phi satisfies if a function phi satisfies the Laplace equation dou squared phi by dou x squared plus dou squared phi by dou y squared is equal to 0, then that phi is called as harmonic function. Suppose if I want to say u satisfies the Laplace equation, then it means phi is equal to u. Dou squared u by dou x squared plus dou squared u by dou y squared is equal to 0. Then u, the real part, satisfies the Laplace equation. Suppose if I want to prove the imaginary part v satisfies the Laplace equation, put phi is equal to v. Dou squared v by dou x squared plus dou squared v by dou y squared is equal to 0. Then we say v satisfies this Laplace equation, then v is harmonic. And note about this. Given that if fz is analytic, if fz is given to be analytic, if it is given, then on the next question, if fz is given to be analytic, then the real part u and the imaginary part v, they are harmonic functions. That means this u satisfies this equation, v also satisfies this equation. So to prove that u and v are harmonic, u is harmonic, to prove that u is harmonic, I had to show this equation is true. Dou squared u by dou x squared plus dou squared u by dou y squared is equal to 0. To prove that v is harmonic, to prove that this v is harmonic, I have to prove that dou squared v by dou x squared plus dou squared v by dou y squared is equal to 0. Now let us take an example. Show that the function u is equal to x squared minus y squared, which is the real part of an analytic function fz. It is a real part of an analytic function fz. It is harmonic. Now what is u? U is equal to x squared minus y squared. What is my job? My job is to find out ux and uxx. That means take u, partially differentiate with respect to x, again partially differentiate with respect to x. If I partially differentiate with respect to x, differentiation of x squared, 2x. Now let us take this 2x. Ux is 2x. Again partially differentiate with respect to x means uxx. Differentiation of 2x, 2. Similarly from u, find uy with respect to y. With respect to y, x is constant, 0. With respect to y, y square differentiation is 2y. Now again let us differentiate this uy. If I differentiate uyy, that is equal to minus 2, take it outside. Differentiation of y is 1. So you got ux is equal to 2, uyy is equal to minus 2. Substitute in this equation, dou squared u by dou x squared plus dou squared u by dou y squared. Dou squared u by dou x squared, what is the value? 2. I have written that. Dou squared u by dou y squared, that means uyy. Dou squared u by dou y squared means uyy. Dou squared u by dou x squared means uxx. Dou squared u by dou y squared, what is the value? Minus 2. 2 plus minus 2, 0. Left hand side is equal to right hand side. That means this equation is satisfied. That means this u satisfies this Laplace equation. Therefore, u is harmonic. So let us take another example. Suppose v, does v x squared minus y squared plus 2xy, the imaginary part of an analytic function, imaginary part of an analytic function is harmonic? This is the question. So let us take v. From this v, I have to find vx. Let us differentiate with respect to x. With respect to x squared differentiation, 2x. With respect to x, y squared, y is constant. Therefore, differentiation of this constant is 0. Differentiation of this constant is 0. From this v, I am partially from 2xy, I am partially differentiating with respect to x. With respect to x, 2y, both are constant. Take 2y outside. So what is remaining? X. Differentiation of x, 1. Now from vx, we are finding vxx. Right? Differentiate 2x, 2. With respect to x, again I am differentiating with respect to x, 2 into differentiation of x, 1. So this is, I am differentiating this with respect to x. So therefore 2y is constant, differentiation of this constant is 0. Now let us take v again, partially differentiate with respect to y. With respect to y, x is constant, therefore 0. With respect to y, y square differentiation, 2y. With respect to y, 2x constant, take it outside, differentiation of y, 1. with respect to y, 2x constant, take it outside, differentiation of y1. Now let us differentiate it again partially, minus 2 into differentiation of y, 1. With respect to y, 2x is constant, therefore 0. Now substituting this equation, what is vxx? 2. What is vyy? Minus 2. 2 minus 2 is equal to 0. That is, left hand side is 0, right hand side is 0. Suppose if you are getting 0 is equal to 2 or 2 is equal to 4, it is not possible. Then in that case I would have said the equation is unbalanced. That means then in that case I would have said v is not satisfying the Laplace equation. Here what has happened? LHS is equal to RHS. Therefore v satisfies the Laplace equation. Therefore v is harmonic. Okay, let us stop at this point.